the trigonometry, which will carries in your ECET examination. Nine to 11 marks. Trigonometry will carries 9 to 11 marks. In this, we have the first chapter name is Trigonometric Ratios. Second is compound angles. Third is multiple and sub multiple angles. Fourth is transformations. Fifth is actually this trigonometric equations up to 2018 they didn't give any question, but recently they were added this chapter also. Next, inverse trigonometry functions. Seventh is properties of triangles. Eighth is solutions of triangles. Ninth, complex numbers. Altogether, how many chapters are there? We have 9 chapters. Among the 9 chapters, we might be getting every year from 9 to 11 marks. In between 9 to 11 marks, we are getting in this chapter. Okay. Altogether, trigonometry is having how many chapters here? 9 chapters. And moreover, we have periodicity also. One more chapter is there, which is periodicity. Okay. Altogether, 10 chapters are there here. Among the 10 chapters, we are getting every year 9 to 11 marks from this unit, trigonometry. Okay. We are discussing about the trigonometric ratios, first chapter. So here, if you see, especially the basics and the fundamentals of the trigonometry have been starting from this chapter only. Trigonometric ratios. In this, what are the basics we have? First of all, the thing is, if you are going to take some diagrams like this. Now, what we used to call this as? We used to call this as a circle. We used to call this as a triangle. We used to call this as a square. We used to call this as a rectangle. Now, how should we identify? How we are going to identify that by seeing itself we are telling this as a circle, this is a triangle, this is a square, this is a rectangle. How it is possible? Means for each and every diagram it has own dimensions. For each and every diagram we have their own dimensions. Basing on their dimensions only, we are going to identify them as so and so is a circle, is a triangle, is a square, is a rectangle, like that. So here, for each and every diagram, we have their own dimensions. All the dimensions are based on only one single point. What it is? Nothing but an angle. Now, first of all, whenever we used to come to the discussion about the trigonometry, first we have to learn about the angles. Now, the definition of an angle is angles of a diagram are formed by the rotation of a ray in a plane around the end points. Angles of the diagram are formed by the rotation of the ray in a plane around the end points. Well, we are going to discuss about the easiest definition about the angle. That means angles of the diagram are formed by the rotation of a ray in a plane around the end points. Simple definition for an angle. Now let us discuss about the angle in a brief manner. Let us say, when we are discussing about the angle, I will tell a simple example to you. Suppose if you are going to draw a straight line in a plane lamina, we are going to point it as A and the ending point it as B. As we all know, if a line is rotated in a clockwise direction, what type of angles we are going to execute? When the line is rotated in a clockwise direction, what type of angles we are going to execute? We are going to get negative angles. If the same line is rotated in an anti-clockwise direction, clockwise direction means this side, anti-clockwise direction means this side. If it is rotated in an anti-clockwise direction, then we are getting positive angles. Let us say we have to make the confirmation about the exact angle, how it is going to be formed. Now see here, if I am going to give the small displacement to this B from A by giving some dotted lines like this. If we are going to give a dotted lines, at a certain point we are going to stop the rotation. Now all of a sudden we want to find the distance between these 2 points. We want to find the distance between these 2 points. How we are going to measure? Because the diagram is simply on the board, if you are going to place a centimeter scale in between them, we can easily deduce the value that the distance between these 2 points is some 10 centimeters or 12 centimeters, because the diagram is very small on the board. Now the same type of diagram if you are going to draw, here on the board we are telling some x centimeters. Now the same type of diagram if you are going to draw in the classroom. Now what is the terminology we are going to use there? Will you use centimeters or will you use in feet? Yes, we have to use that measurement in feet, FTS. Now the same type of diagram if you are going to draw in a playground, if you are going to draw the same type of diagram in a big playground like cricket stadium, if you are going to draw the same diagram in the cricket stadium, then what type of terminology we are using to find the distance between those 2 points? There it is not possible to measure in centimeters, even though it is not possible to find in feet. Then the alternate terminology is what? Meters. We are using here meters, MTS. Now the same diagram if you are going to draw on the road, where the first point is our VEDA institute and the next point is somewhere the destination. So on the road when you are going to draw the same diagram, what we will do? We will change the terminology. Will you measure in centimeters? Not possible. Will you measure in feet? Not possible. Will you measure in meters? Not possible. Then what is the alternate? Now that alternate measurement is in kilometers. So see here, only one diagram we are going to measure in 4 different methods. We are going to measure in 4 different methods. Is it possible to maintain the same type of measurements for all what do you say, circumstances? No, it is not possible. That's why what we have to do, our ancestors had given a conclusion that if you are going to draw an arc in between the two lines, if you are going to draw an arc in between those two lines, that arc is called angle. By knowing the conclusion of this angle, we could able to determine each and every high level distances on this part by using so-called angle only. Remember this point, my dear students. Well, definition about the angle, what I have given, angles of the diagram are formed by the rotation of a ray in a plane around the end points. That's it. Very simple example for the definition of an angle here. Now next, when we are going to discuss about the angle, measurement of these angles are of how many types? The measurement of these angles are of three types again. First one is sexagesimal system. Second is centesimal system, and third is radian measurement system. First method is what? Sexagesimal system. Second is radian measurement system, and third is centesimal system. Third is radian measurement system. In sexagesimal system, see here, the unit of measurement of angles are in degrees, whereas pi radians is equal to 180 degrees. Whereas pi radians is equal to 180 degrees. Is equal to 90 degrees. One degree is equal to 60 sexagesimal minutes, and 1 minute is equal to 60 sexagesimal seconds. Okay, next, after this we have centesimal system. This sexagesimal system is regularly we are using for the measurement of every diagram, whereas in this sexagesimal system it is very easy to remember. In radians and degrees we have a very close relation. Pi radians is equal to 180 degrees, and one right angle is equal to 90 degrees here. 1 degree is equal to 60 sexagesimal minutes, and 1 minute is equal to 60 sexagesimal seconds. Clear? Second method is centesimal system. In this, the unit of measurement of angles is in grades, that is pi radians is equal to 200 grades. While you are comparing with hexadecimal system, it is quite opposite and entirely different it is. Now in this, what we are going to do for this? One right angle is equal to 100 grades. 100 grades, and 1 grade is equal to 100 centesimal minutes. and 1 minute is equal to 100 centesimal seconds. 100 centesimal seconds. Whereas comparing with sexagesimal system, in that we have in degrees. Pi radians is equal to 180 degrees. In this centesimal system, pi radians is equal to 200 grades. One right angle is equal to 100 grades, and one grade is equal to 100 centesimal minutes, and 1 minute is equal to 100 centesimal seconds. Radian measurement system. In radian measurement system, the unit of measurements of angles is in radians. Simply, we used to write for this as 1 radian is equal to 2 by pi right angles. 2 by pi right angles. And this system is widely used for the measurement of circuits. This system is widely used for the measurement of circuits. Totally how many methods of measurements are there? We have 3 types of measurements. One is sexagesimal system, second is centesimal system, and third is now radian measurement system. Relation between sexagesimal system and radian measurement system. See here, we all know that pi radians is equal to 180 degrees, whereas 1 radian is equal to 180 pi by 180. So it is 1 radian is equal to pi by 1 degree is equal to pi by 180 radian, whereas 1 degree equivalent value is 0.01732 radians, which is an approximate estimation. And 1 radian equivalent value is 180 by pi, which is equal to 57 degrees 17 minutes 34 seconds. It is also an approximate estimation. Pi radians is equal to 180 degrees, and 1 degree in radians, whenever we are writing, we have to write it as 0.01732 radians. Whereas 1 radian equivalent value, if it is been converted into degrees, then we used to write it as 57 degrees 17 minutes 34 seconds. Now here one thing we have to remember, that instantly without using calci, can you tell the value of sine 57 degrees 17 minutes 34 seconds? For any trigonometric function, by substituting this value, will you get the instant value orally without using any electronic gate? Isn't it? So we can't able to express the value for that. That's why we used to write this as 60 degrees, because 57 degrees 17 minutes 34 seconds is the value which is near to the round figure value as 60. Remember, this is a very basic important point. 1 radian equivalent value, whenever we are writing, actual value is what? 57 degrees 17 minutes 34 seconds. But instantly we can't able to express for that the answer what it is. That's why what we have to do, we have to make it as a round figure value. What is that? The round figure value is 60 degrees. Now we can tell easily what is the value of sine 60? Root 3 by 2. What is the value of tan 60? Root 3. What is the value of cos 60? 1 by 2. Like that. Clear? Converting radians into degrees. See here, we have pi radians. Like just now I taught you that pi radians is equal to how many degrees? 180 degrees. If I divide this pi by 2 means what? We have to write it as 180 by 2. 180 by 2 means what? 90 degrees. Now see here, if it is pi by 3, pi by 3 means what? 180 by 3. 180 by 3 means what? 60 degrees. Pi by 4. Pi by 4 means what? 45 degrees. Pi by 6 means what? 30 degrees. Now can you answer what is the value of pi by 6? Pi by 5? What is the value of pi by 5 now? It is written like 180 by 5 na? 180 by 5. 180 by 5 means how many degrees na? 36 degrees. If it is 3 pi by 4 means 3 into 45 degrees. How much it is? 135 degrees. If it is 5 pi by 4, so 5 into 45 degrees. How much it is? 225 degrees. If it is pi by 18, pi by 18 if it is given. So how much you have to write? 180 by 18. Means how many degrees na? 10 degrees. Like the conversion, converting radians into degrees is very simple and very easy for us. These are very simple concept it is. Pi is 180 actually. So pi by 2 means what? Immediately 180 by 2 you have to write. Pi by 3 means what? Immediately 180 by 3. Obviously 60 degrees. Pi by 4 means what? 180 by 4, 45 degrees. Pi by 6 means 180 by 6, 30 degrees. Pi by 5 means what? 180 by 5, that is 36 degrees. Like this we can make the conversion very easily. Clear?